experience. I have an experience maybe which I can share, which was just today. So sadly, there was a feature we're working on at work, and after I told the front end dev to memaliza, and they can start testing, just at first glance they realized that this is not going to work, and the fault was on me. The fault was on me. I had assumed a few things, and well, that experience that you have, or that joy that you have of finishing a task, then you realize, oh wait, there's a problem somewhere. So it's a bit discouraging, but anyway, we live, we learn, right? So is there anyone else with an experience where they had, maybe done something, thought they had finished, and even just to make it a bit more open, if it's not tech related, just say it. Anyone? Evans, Charity, Janet, of course, huwezi kosa.
Unajua umesema mpaka ya out of si lazima ikuwe tech.
Yeah, please.
Buka kuna nguo yangu lazima ipigwe pasi. Part of maintenance. You bought it, you have it. Yeah.
Hey, awesome. Anyone else? Thank you, Janet. Ida. Sam, Sydney. All right. So going once, going twice. All right, cool. So we're going to introduce today's speaker. His name is Chirchir. Hiyo jina inanisumbua kusema. My apologies. But his name is Chirchir Kipruto, and he is an infrastructure engineer. So karibu sana, Chirchir. The floor is yours. Kindly take us through the session. I hope you can hear me, Kipruto.
Yes, I can hear you, Rem. Can you hear me?
Yes, I can hear you. Awesome, cool.
Nice.
So
nice.
maybe you'll take over.
Yeah. I'll be taking over.
Awesome.
I am the captain now. So
Karibu.
Hi everyone. My name is Chirchir. I see some few familiar names here. I think I've met half of the people I see here. Janet, the others in the background. Yeah. That's in the community meetings and the other tech events, the Kenya Tech Space. So I'm an infrastructure engineer. I work at N4 Agile Business Solutions Limited. So mostly do ERP deployments and bespoke software solutions. So in infrastructure, your day goes anywhere from VMs being down in Azure, you need to set them up, to as far as creating codes for a client who wants their servers deployed. So lots of things happening between there. It's infrastructure. So that means anything that is built or anything that is coded anywhere. That's your job to make sure that it runs and the company doesn't start hemorrhaging money because someone deployed something wrong or you lost access to an environment. So our talk for today is going to be maintenance. So when we hear maintenance, your brain automatically goes to the maintenance options for corrective, adaptive maintenance. You have perfective maintenance, the monitoring side of things, but maintenance takes a lot more than that because as much as you can know the adaptive maintenance, the preventive maintenance, there's also the hard grunt work that you have to do when you're maintaining stuff. So that's what we'll be talking about today. Yeah, let me share my screen. Can you guys see my screen?
Yes, we can.
Yeah. So system maintenance and operations. I think if you are in any tech company or you've worked or you've met people, you've had the guys who talk about IT operations or IT maintenance. So we'll be looking into some of the things they do on the daily. Depending on the roles you're handling, if you are on the front end side of things, the back end side of things, you've probably interacted with guys in operations. Those are the guys who ensure that they are on your neck if either your system is consuming resources or something is going wrong. So let's look into what they exactly do to ensure that what we've built stays alive and you don't have to keep telling your customers every single time that we have downtime and we're going to be up in a couple of minutes. So today, this is a comprehensive guide to maintaining secure, reliable, and scalable systems in production environments. So think of a system that is already live anywhere, any system that you can think of, whether you've built it, whether you've been using it. So this is what goes on in the backend. Yeah. Mm. So maintenance. This is the critical phase. The other previous phases you had looked into for the SDLC, you have the development, the deployment, the testing phases. So this is the last and the longest phase in that SDLC lifecycle. So it generally happens from anywhere after your system is gone live. I think it's probably infinite because there is no time you have maintenance ending, because when maintenance stops, that means you're either decommissioning the system or moving to an entirely new system, which also picks up the maintenance side. So maintenance is probably the longest phase, and it's also the most important phase because it's the defining factor of where you've already built a great system, but can you actually sustain it in production? Because as great as any system is, if it's experiencing downtime frequently, it's not up. There's security issues. If you can't maintain the system, then most of the users will probably shy away and go to the other plan. So maintenance is the longest and the costliest and the most business critical phase. Once you have active users, your focus tends to go from building features most of the time to also protecting reliability because, as Rema has mentioned, you can build great features and push them to production, but unless the users get to actually experience those features, you won't get any rewards for your work. So, and that's where the companies make money. Infrastructure maturity, process discipline, and observability, they all intersect here. Any cracks translate to lost revenue and dissatisfied users. So when maintenance fails, you rarely get to make any money and bills got to get paid. Yeah, configuration and infrastructure integrity, that is what we're starting from. So uh, across the community, we've had several instances where we've been talking about configuration, infrastructure integrity. Patrick here is one of the Terraform heroes we have around, the guys who are experts in HashiCorp, so maybe he can talk more about IAC. But part of managing infrastructure goes into ensuring that your infrastructure is up and running. So at some point, once your system goes live, you will want to scale or upgrade it. So you are advised to use infrastructure as code tools, that is Terraform. You have the playbooks with Azure, and you also have the AWS CloudFormation. So you tend to run into a case where there is configuration drift. You deployed a system last month, someone changed it in production, they didn't edit something. So when you're either upgrading it or changing something, you're trying to apply, but it's not running. For the entire state of the system that's already running, it's different from what your state logs or your configuration files are showing. So you want to remove the drift. Production drift is when production configs no longer match the source control. That is when manual console changes in AWS, Azure, or if you're using Ansible, you find that someone changed something on a config, but there's a drift, so you can't really tell what exactly is existing in the system or its current state. So the most common causes is this is when hybrid environments with manual changes, whether you have hot fixes, you're creating a new cluster, you don't using the IAC, that's where the patches start to pile up because you're fixing something today, you're creating a different timeline. So the way the config changes work is if you watched anything that deals with timelines, that is whether it's the film lock or something, any change that is done, you create an entirely new timeline from the main branch. So you can think of it as the main timeline. So if you change something in production and you don't remember to update the main configuration file, you're basically creating a new timeline of that. And unless it's merged to the main timeline, no one will be able to tell of its existence. So some of the things you can do to resolve this is Terraform now has Terraform Plan. If you've been using it, it's a great thing. You can use Plan or something like DriftCTL. So with DriftCTL allows you to, it's like an ISE tool that tells you how to check the differences between the current infrastructure that is on the cloud and your actual state that you're trying to run, whether it's the code base or the state files. But it's more of an enterprise tool. But if you find the free version doesn't really offer much, but it's very efficient if you're running multiple environments in different cloud providers. So it can help with that. But if you're running on Terraform using Terraform Plan, this also translates to having one person changing the infrastructure. If you guys are changing things, you want to have one person that's keeping track of the files and what is changing there. If you have people accessing the console, if they're changing things, you want to at least keep a log of what has been changed so that if you're going to need to upgrade something, that is where you're going to start from. Once you've done Terraform Plan, the usual next step is usually to try with Terraform Apply so that you can reassert the declared configurations and move to deployments. Uh-huh. Best practices for infrastructure as code. This is for when your systems are live. So this is you've created the perfect Terraform template, you've run it, it's now working. So one of the things you can do to ensure that the maintenance phase for that system that is exactly being deployed, you are able to use the best functionalities for it. So one of the things is regular planning. So you should run Terraform plan regularly to compare the desired state versus actual state. This goes for those guys who keep deploying things with Terraform. It's a really, really powerful tool, but go through the process of Terraform plan, Terraform apply. Remember to always plan and see what is there and what has been changed. If at all any of the changes is going to disrupt anything, chances are most of the runs won't work. So be planning it. The other thing is state management. Right now, you have S3 native looking with the backend with S3 as the backend here. So previously there was a lot more steps involved in using S3 as an state lock, but right now Terraform natively supports it. I think it's with Terraform 1.8. So you can use state management and state locking with S3 so that if you have multi-user environments, when someone tries to run Terraform plan, this one here, it automatically checks the state here so that if there's anything being changed in that config, it will hold the changes and will prevent any chances of corruption so that you don't have multiple states running at once. You only have the one state as the source of truth. You can do periodic dry runs. This is mostly for Ansible and Helm. So if you're running Ansible, you can also use check2 and the Helm difference. This will help you detect any drift detection so that you have a playbook. The playbook is for infrastructure deployment. You want to check that what you're trying to deploy is not very different from what is already running in the system. The centralized variables, I think if you've used Terraform, you know to always keep the variables and values version controlled. That's for reproducibility and access across different environments. So you want to create a store of all your files and playbooks and who changes what so that you can control exactly what is done to the infrastructure. You can't always say that everyone is capable of deploying things. So keeping track of what is done by who and where, it saves you a lot of time in the future. System and software updates. So yeah, systems in production, they usually have to go through updates. You have the code updates, you have developed the pipelines, your DevOps pipelines are running. So those ones are mostly handling the code pushes and any changes you make throughout all the other phases. You have the development, the deployment side, you have the testing side. This assumes that you already have those phases locked in. You have the pipelines done, the DevOps side is sorted out. So you also want to do the upgrades to the system. This mostly relates to where your system is hosted. When you're doing any system or software updates, you want to first of all check the compatibility across the OF libraries, containers, and orchestrators before upgrading. So there's a chance that you've seen people complaining about they upgraded a cluster and the cluster went down, production was down, or someone decided to update Windows in the middle of the day, or someone decided to do some update to some tool. You didn't check the compatibility, didn't check any variables, didn't check any changes. So this goes back to checking who does what. So you want to be sure that you have read the manual for every release for every software. Before you decide to upgrade something, there should be a change approval procedure for it. You don't just decide to run the update for something. Updates could probably break things and you won't even have enough time to fix it because downtime is lost revenue. You want to upgrade all environments and confirm compatibility before you attempt running anything in production. This goes for those, if you have the test environments and you have the development environment and prod, the first places you want to update is your dev environment. You can always rebuild that, and then you want to see the test. If it works in test, because generally production should be a mirrored copy of the test, albeit an even larger infrastructure, but you want to be sure that if it's running in test and test has the same version as prod, you could be safer. So try to run the upgrades first in the other environments before you touch prod. Use blue-green deployments for environment changes. We went through this during the testing phase of the SDLC lifecycle. Blue-green deployments, this is where you have users being redirected to different places. You have multiple environments or blue and green environments serving traffic. So be sure that if one environment is updated, the other one is not, and then you can track the usage and then see the performance of the environment after the upgrade so that if there's any issue, you could be able to catch it early on. Read release notes and vendor advisories. If any change is going to bring an issue, this is has been a trend for most of the software providers. They usually tell you in the release notes. You can read the advisories and see what is going to work with what. And if you need to make any changes, you can see it. For the guys who've been working with code, the Node, Postgres, and all that, the versions of the Django, if a version is needed by an environment, you'll be told what is compatible with that. So try to stick to that when you're upgrading something so that you don't touch an already set up environment and break everything down. You want to maintain staging replicas for smoke tests. So staging replicas, these are the environments where you have a replica, but you want to see can this exact feature or version run in the state so that before you push any change, you want to have it done first in the states. Critical reminder, a working latest container locally doesn't guarantee compatible kernel drivers in production. You always test, snapshot, and roll forward carefully. So if your system is updated to the latest and it works, that doesn't mean it will work in production. There's an entirely different setup you usually have for production. So if it works, go to the development environment. Does it work there? Go to the test environment. Does it work flawlessly? And then you can now think about upgrading your production environment. Yeah, token and secret management. In production environments and even in test and other environments, you usually have tokens and secrets being used by different systems. So if you're using any tokens and secrets, there is a specific way you're supposed to manage those tokens and secrets. If you've seen how devastating any leakage of tokens happen, because you lose API keys, your API is gone. You've seen the post, oh, API is gone. Someone has managed to get M-Pesa the large API key for someone. And that could be a very devastating thing. This goes even for the other token and API keys. So this is some of the things you can do to manage your tokens and secrets. You have secure storage. You have Azure Key Vault, there's Hagic Vault, there's also Secrets Manager. You never store your secrets in code. This is just common sense. Use the key vaults where possible. It's really recommended that you use them. You are now in the maintenance phase of a system. You're not just still developing it. Your system is already live. You already have users. So you want to keep your token safe because you have commitment to customers to preserve their data so that any leakages in security, you can be able to track them in time. You have automated rotation. These are also some of the best practices you get with. You're told to try to incorporate into your culture with security. So your keys will age like milk, not wine. So enforce the 30 to 90-day rotation cycles. This is mostly handled by the security team, but it is upon you to ensure that keys are rotated after a while. Please don't hard code keys. Ensure that your keys are rotated. Uh, Most of these vault systems, they now have ways to ensure that your keys are rotated. So you can automate that process. So the only part left for you is to check that your system now uses the most recent keys. You have code scanning. If you are in the enterprise side, you can use the GitHub Advanced Security. it's paid for enterprise. I think for GitHub Enterprise, an enterprise plan. So you can also use Truffle. Mm, yes. So Truffle, let's write here. For those who do the security pattern scanning for code, when a system is going live, everyone is careful about what they're deploying. You mostly want to get everything checked, you want the boxes checked. But as time goes, you begin to get complacent about managing security for the keys. People start doing. You want to push the feature to production as fast as possible. It is understandable, but you also want to stay secure so that you don't push to production and unintentionally bring everything down. So you can use a tool like TruffleHog. There are installation steps here. You can check it out later. So with TruffleHog, it's basically goes into the code and scans for any hidden secrets. The way TruffleHog works is that when you push a commit, it does pre-commit and pre-save fork so that before you actually push any code, it first of all checks that there is no security issue with the keys and something there, so that it can instantly analyze, prevent, and remediate any leakage of keys. It's not that you're not careful enough; it's that people forget. They want to prevent that, so you want to also account for human nature. Yeah, another great tool you can use is SonarCube. SonarCube takes a bit more effort to install because you have to host it somewhere and then direct all your repos, connect all your repos to it. But it's a really great tool for checking code security. It checks the databases security for any APIs accessing databases, does checking for security for the code, does the static, the dynamic checks for the code. So it's a really great tool to incorporate when you're now working with production because repos tend to get large. The more features you push, the larger the repos get, the more complacent people get. You have different people working on a system. People move, employees change, but SonarCube will still be there after. Access control. Apply role-based access control and just enough privilege when creating keys and assigning accounts permissions. You need to review regularly and monitor any access log. So when it comes to creating keys and assigning account permissions, development environment is different from test and entirely prod because if you're developing something you want to see how the key performs if it has the most permission. So when you're narrowing down permissions for keys in production, you're maintaining a system that is live. So if any keys are being changed, retain the same permissions they had, unless that specific key is being used for access that requires even more permission. You want to stick it to the list, just enough permission in creating the keys. You can keep reviewing the keys regularly. So this is tied to the rotation cycles for the keys. Review the keys until you just have enough permission. Control progression. This is the shift right. So shift left is where you're adding testing and security first before going live. But once the system is live, you now have the shift right. This both they can both work in production because you now have a dev, test, and prod pipeline, which is basically how everything runs. You use DevOps tools for control. Prod pushes are only automated, and there are no manual approvals and test cases passed. You now have each environment maintaining separate secrets and credentials. I think this one shoe is mostly enforced, probably on the back end, that the keys that are used in dev are not the keys used in prod or test. So you only ensure that the keys in dev they can never work in prod. So that if anyone at all gets access to the keys in a different environment, they can't do any vertical changes with it. So one of the things that I mostly come to see the best part of is the disabling force push on GitHub. So a while back, I didn't know this actually existed. So when I discovered it, yeah, it really helped things because you have people who are being pushed to develop, deploy, and someone wants to push their changes. So they'll just do git push force, blow everything up. But no force pushes ensures that they can't force something to work. They must go through the established procedures for deploying their code. Shift right is where you're now testing things. You probably end up testing something in production because as much as you try to do it in testing, some things will you can only test when it's live, like Mambo ni live. It has to be in production so that you know this thing does it actually work or not. So there's some of the shift right practices you can do is the you have feature flags to test safely in production developers. Observe user metrics, expand rollout gradually, and also practice chaos engineering for confidence. So there is never an overly optimized system. At any point, you're trying to save resources, you're trying to save memory, you're trying to save time. So a transaction that takes 5 milliseconds could probably take less than 5 milliseconds. So I think it was Node. Uh, a while, I think last month, there was an issue with the node, the main node repository for updates. So the way someone discovered it was that they checked that their SSH login takes some microseconds longer than it really should. So when they tried to debug it, they ended up discovering that someone had intentionally inserted malware into the SSH login. It's a really interesting discovery. So you need to optimize your systems regularly. So part of it is practicing chaos engineering. If you've read about chaos engineering with Netflix and something, it's something that you want to do when you have the resources to try it out because can your system actually recover from any loss? If the cloud provider goes down, do you have the procedure set up to recover from it? So controlled progression is shifting, right? So controlled progression is basically stick to the same pipeline. It's developed, it's tested, it goes to prod. You can now test, use the feature flags, do the blue-green deployments, and then the gradual rollout of things and testing. So try to stick to the pipeline when working with an already live system. Vulnerability and code scanning. This is for Truffle Hub and SonarQube. They can work with the CI integration. So CI integration is when you put it in the CI part of the pipeline. So DevOps, you have CI and CD. So with CI, this is mostly the first part. You can use the code checking tools like SonarQube and Truffle Hub. You have the large repos. You need someone to be checking their security, and nothing works as good as having an automated tool. It can also help you a lot of exposure later on. Yeah, you have periodic rescans. So periodic rescans, they will mostly help you configure regular rescans of legacy branches. I wish I had it deployed, but SonarQube, I don't have access to it on the machine now. I would have shown it, but SonarQube really, really works. If you've not used it before, please try to deploy it. It's a very lightweight system, but you'll need access to the exact environment. I think they have ways to deploy it in Docker. You can check that out. Yeah. Monitoring, observability, and decision making. So, monitoring and observability. For the most of the common names you have Elasticsearch, Logstash, Kibana, Prometheus, Grafana. There are so many tools you can use to do the monitoring part, but you have to think that you're not just staring at the metrics and seeing the colorful dashboards. When a system is live and you're maintaining it, those dashboards are where you see the leakage happening in real time. So you need to read the metrics very, very effectively. So one of the things you want to look for is the CPU and memory trends. Uh, for those guys who deploy on Windows, I've been known to do that sometimes. Windows is notorious for being incredibly slow. One of the things it does is you have very entirely different way of handling memory and access in Windows. That is for the databases, if you're using .NET for the code. So you want to check, you want to use the dashboards. Although most of the tools are not built for Windows, but having the dashboards really helps you see the high usage and the service performance because you have something like a task manager for Windows. It also works in Windows Server for 2025, 2022, and previously. So you can also use that to check. For Linux, you have most of the other tools they're built mostly for Linux. So check the CPU and memory trends. You want to be sure that CPU usage is never high enough. If you've done any of our last projects, you'll see that there is a part where we were checking for auto scaling. So this is mostly related to auto scaling. If at all your autoscalers are built for 80% CPU, 80 and above usage sustained for around 5 minutes, this should not be a recurring thing because then it means that if a system is using so much CPU and memory, either there's a part of it that needs to be optimized or there's something else that is latched onto it that is wasting memory. The request latency, this sometimes relates to the way the system is built itself. Something could be working fine in test, but in production, when the users are live, you tend to see a spike in usage. So this is this is what you want to be looking for. One of the things I've seen can help is the exponential backup for any retries on your system. So retries help when you want a system to work efficiently so that any requests don't get thrown away or they don't get halted or they don't get stopped. They keep retrying it. But if you have three different parts of a system, part A is retrying twice, part B is retrying twice, part C is retrying twice. You have like eight retries happening in the system. So at some point, your system will end up DDoSing itself because you have retry after retry after retry after retry. If you have not implemented the exponential backup, where the exponential backup is basically you telling the system that try retry this many times within this many seconds so that you don't have the retries lagging on the whole system. You can also try to optimize the system and then also work with that. You have the error rates. You can correlate the spikes with recent deployments for root cause analysis. So a little bit of threat hunting involved there. You don't have so many users, so your system should probably not be using as much memory every given time or auto scaling itself. Throughput. You need to monitor for seasonal or promotional spikes requiring capacity adjustments. So if your system is mostly being used in the service industry, you will generally see an increase when your users are using it, but you don't expect to see a sustained increase at a time where users should not be using it because then that means either something is wrong with the system, there's an issue with access to the system, or there's just probably an attacker in the system. Some of the actions you can do is you tune the autoscalers to respond to fluctuating demand. You can also provide API throttling. This is for those who do the managed API services. You have the API gateway. You can check that the throttling is also done for those APIs and caching for any burst control. You have report anomalies proactively via stakeholder dashboards for visibility. You have investigate any sudden drops in performance or sudden increases in error rate. So basically, this is the observability side of things. So you want to be sure that you're not just looking at the dashboards, but you are hunting for what could probably help you make better decisions in maintaining the system. Some of the some of the things you can use, you have provider-driven insight. So provider-driven insights, if you're running a system on cloud, yeah, if you're using AWS, Azure, or GCP, you have there are given tools that you can use to manage your monitoring side. So you have Azure Monitor, great tool. You have AWS CloudWatch, you have GCP Operation Suite. So make so much use of the systems. You can still use the free version or the free limits for the systems, but they really help you to see where how your system is performing in production because in production is where really the monitoring and logs and metrics they help you maintain the system because if you can't see how the system performs, you can't run any help on it. It's like symptoms. This is where the symptoms go. If you know the symptoms, you can better treat the issue. Root cause visibility, you need to combine the logs and distributed traces to pinpoint the exact source of issues across microservices. So it takes a little bit of time and you have to know what you're looking for, but once you've optimized your autoscalers, your monitoring systems, you should be able to see where the issues are coming from. You have automated alerts. You need to configure anomaly alerts to communicate critical incidents. Kudos to the guys who use Slack for for its integration with Grafana and also the other tools. So you can also use Teams, but Teams take a fair bit of configuration for it to be sent there. It needs specific access, licenses. You can also use other email channels, but the best tool you can use for automated alerts is Slack. You can set that up some other day. Scaling strategy. So your scaling strategy is probably what helps your system survive any spikes. And you want to think of scaling as just a living policy. It's not just an event that happens when something goes bad. Planning for the scaling ensures that you don't really end up in a position where you want to scale your system fast and you are not even planning for it. So one of the things you can do to ensure that your system is properly maintained is just changing your scaling approach. So you can change it with fine tuning your thresholds based on historical metrics and performance forecasting. Spot instances, sustained usage, network traffic. This is where you fine tune the threshold. So if you don't intend for your system to have usage above 80%, if you keep getting usage 80% at odd hours, then there's something wrong with the system. You also want the thresholds to be as close to meltdown as possible, because if your system still performs well and it's at 60% usage, you don't want to start scaling the system fast. That is another cost element you don't want. Ensure that you have fine-tuned the system so that when you're deploying it in the first place, the resources that you're configuring for it, they are allocated properly, that you don't need to start scaling when the users come in. That is where the analysis during the deployment phase happens. So you also have to combine horizontal and vertical scaling with the autoscalers. This is related to Kubernetes. Are you getting more nodes? Are you improving the clusters? You have to ensure that load balancers distribute traffic evenly. You have to really fine tune your load balancers, because if you have the scaling thresholds done here, your load balancer also need to align with it. So will they perform when you want them to? Deployment first. Ensure that you test everything maximum. You should also make use of spot and on-demand instances for any side capacity. So on-demand instances, self-explanatory. This is when you want an instance done, you create it, you build it. Spots, this is only for ephemeral usage, so it can go at any time. You can also use the reserved spot instances, but depends on the exact cloud provider you're having. The expansion steps: analyze utilization, forecast demand, add worker nodes of VM instances by infrastructure as code. So the first part we are going through, configuration drift. System usage spiked. Someone decided to create a new VM, deployed the resource to the VM, added it to the DevOps cluster, and traffic is going to it. They didn't even bother to update the state. They didn't use IAC. So you see where the configuration drift now comes in, because you're maintaining a system. A system is expanding, but you're not sticking to the basics of deploying the system. So try to use infrastructure as code on every single time if you're changing any changes in the system. So do that. You need to rebalance the workloads. This is the cluster autoscaler. So if you are expanding a cluster, uh, try to see the long-term usage for it. So if you have workloads in a strained node, one of the things you can do is drain the node, balance the workloads across the different clusters. Because if you're expanding one side, you don't just want it running that specific workload. Because if at all the usage of that cluster is lower than 40%, you might want to increase it and then balance out the other nodes which are around 60 or 80%. So move some of the workloads to different clusters. So you have the health at 50% anytime. Verify network bandwidth and DNS propagation. DNS is always the culprit. If your system is down at some point, if DNS is not the issue, then that's an even bigger issue. But network bandwidth and DNS propagation. So when complexity increases, you also have to factor in the DNS side of things. Ensure that the certificates are always valid. Uh, if you've deployed any system, you know about SSL certificates. Some system security features, they simply won't work if your SSL certificates are invalid. So to save yourself the trouble of having to go go again to the provider, start paying for the SSL certificates, have it installed on the system. So set up the automated alerts for SSL certificate expiration. So there are tools that monitor that. You can also factor that in with your provider. There's also the self-renewing SSL certificate, so that you won't even have to redo the whole import a certificate, install it, add it to the workloads, change the current certificate, because as complexity increases, we want to also reduce the number of moving pieces in it. So you also need to check that the domain is properly set up. When you're doing the deployments, you got a domain from someone. You need to ensure that the DKIM status, this is for security of the domain. Ensure that they are all done properly, because as much as your provider will try to protect you, it's upon you to ensure that your domain is properly set up, because domain takeovers happen. You want the DNS records to be very well secured. Reliability, failover, and disaster recovery. So, disaster recovery, problems happen. You want to be sure that your system will recover after a disaster happens, because no one really predicts a disaster, but what happens when your system goes down or your provider is down. So you want to maintain a hot or warm standby architecture. This was more touched on in the deployment side, but in maintenance, you want to be sure that they are actually there. The hot or warm standby systems, they need to be there so that when anything happens to primary, you can immediately fail over to it. So you need to maintain both. They should be fully active and real-time replication. So for databases, if you're not using the global tables, you're not using the Aurora, the global sites, and you're also not using replication, you're probably waiting for disaster to happen, and chances of you recovering will be very low. If you're using SQL Server, please try to set up the replication. It's 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 a very simple process to set up. Set up the provisioning, set up the replication, ensure that replication works, and also that the replicas they should be live and working so that at any given point, if your primary goes down, the failover happens, and then you're not stuck in a state where you're trying to failover, but the failover replicas they're both not working. Maintain the replicas and then ensure that for the worm, it's provisioned, inactive, and ready in minutes. Standby sites for environments ensure rapid recovery. So you are in production, you can always find a way to have a smaller sized environment for replication. Intelligent traffic routing, this is for DNS health checks. Traffic managers intelligently route user requests, continuity. So ensure that with Route 53, your health checks are properly set up, and then you have them drilled down almost obsessively so that if you have any issues with DNS, Route 53 can probably help you to propagate to a different instance. This also works for on-prem. You can have different environments where you set up the DNS propagation. You can use the proxies and that sort of thing to check out DNS. But with DNS, you also have to be sure that your records are okay because if a system goes down or if you scale it, the whole provisioning pipeline could probably take a while. So ensure that you're using the cloud, and when you're using it, take advantage of health checks. You have proactive failover testing. Conduct random failover drills regularly to validate response times, system resilience, and effectiveness of your disaster recovery plans in real world conditions. Uh, what happens if your system goes down now? Most of the providers last week they were caught out when AWS went down. Admittedly, some of the steps they could not prevent them, and most of the failover systems they were tied together. But it's upon you to ensure that unless it's a provider related issue and everyone is affected by it, try to test your failover procedure regularly so that in case something happens and you are down for like a minute or 10, your system can probably fail over to the next region. But if you can't, you have a separate way or a failback option that's past that. This is for the disaster recovery side. You also have adaptive instant incident response. This is for implementing automation that differentiates between service degradation and complete failure. So there's service degradation and there's complete failure. Service degradation, this is where requests probably take a lot longer than they should, but the system is not down. There's probably a spike in usage, you're waiting for scaling to work, but the system is not entirely down and inaccessible. So your failover procedure should be able to check for this. So is it failing over or is it auto scaling? So ensure that the degradation is handled by auto scaling that is properly set up, and the complete failure is handled by the failover. So can your system survive degradation? Probably by auto scaling, but complete failure, you need to have failover and disaster recovery setup. So you can respond with throttling, caching, or minor scaling for degradation and full traffic redirection for total system unavailability. So deployment and improving it. Failover and failback procedures. So a well-defined strategy minimizes downtime and ensures business continuity. It's a choreography of precise steps. So the system is live and then you've failed over. So the process could probably look something like confirming the outage. You need to check the CloudWatch alarms and other monitoring systems to confirm outage and its scope. If you had the alarm set up for the monitoring, you should probably have gotten an alert that the system downtime. If you used Azure, there's the alert, the availability is less than zero or less than one for a system. or a VM. So if you have that setup, you should get an email for it. You can confirm the outage by going to the console and checking that the system is completely out. You need to verify the data integrity, most important part. So check that the replication status. If you set it up properly previously, the read replicas should be up. And then also replication to S3, it should be healthy. If it was not healthy, you probably have a data loss on your hands. So that is the point you now start tracking the RTO and RPO. That is where they immediately start coming in. So recovery time and recovery point. So how much data are you exactly using or losing during that downtime? Confirm that multi-region instances of prior application setups are in place. So this is not the time to panic. This is the time where you want to see that your preparations are really getting tested. So we also have activate disaster recovery sites. If the site was not already activated with the failover procedures, this is where you now activate it. You now start the EC2 instances. This is for the warm standby ones. You also have the EKS nodes and also other compute resources in the warm standby site. So if they're not already activated, you activate them. You now promote the databases and read replicas to primary status in the region. Do this through the console so the databases is backup. This is if the data integrity was properly done. So activate those. You now have DNS routing. So update any DNS failover routing policies for Route 53. Do do traffic direction and also activated DR site. So check that the endpoints are all working so that if you had like dr.erp. something, this is the time when you check the link is working. Send the emails to people, send the emails to users and tell them you're having an issue, please access through this. Or if it's a really big system, you won't have to send the emails to just redirect traffic to your failover site. So, and then the health checks now come in here. So if the health checks were okay, they would have redirected to the DR sites, the DR links. If they were not okay, you have to do it yourself, which is a bit more work. You now have to confirm user redirection. You can do the NS lookup and then see whether your links are actually resolving to the failover site. So once the primary region is restored and validated, you now have to do the whole fail back process. You also don't want to stay way too much in the failover site. You need to fail back to primary. So you resync the data, ensure that the data is fully resynced back to primary from the DR to prevent any data loss. So that's where you start ticking the RTO and RPO that the limits were actually within acceptable ones. You have switch DNS. Switching DNS, this is going back to the routing side. Ensure that you fail back to primary for DNS. If the health checks do not already do that, you need to gradually shift the traffic back to primary so that also failing back immediately could be an issue because your system probably went down because of a failure. If you fail back immediately, maybe the issue is still housed inside the system. So try to fail back slowly as well. So redirect part of the users back to primary and also keep some of them running in DR. Decommissioning or revert, you can decommission the DR site or revert it back to home standby so that, and then check that replication is still working so that any future instances you can also still recover for it. Cost management practices, the money. Uh, any system should be justified when it comes to money. So you need to justify the usage of resources. You need to justify the allocation of resources for it. What is the cost of the system? Is it really making revenue for the company? So a system in production, you want to be able to track the revenue that the system makes and what goes into the system and what exactly does the system do for it. You have the systems that you are selling, you have the solutions you're selling, and then you also have the internal consumption too. So if your system is lying between one of those or is any of those, you should still ensure that the system doesn't waste CPU cycles of money because the finance team does not care about what the system does. They care about how much it costs them to run that specific system. How can you justify it? So you can do things like resource tagging. This is for managing the costs. So resource tagging, when you are deploying any resource, it's it's not a required thing, but it's a very important thing for it to be done. So tag all the resources by environment, owner, and projects. You should show finance where every dollar goes. So you can set policies to explicitly require this so that any resource that is deployed without a tag It either raises an alarm or prevents the resource from getting deployed. You have weekly reviews. You can start with weekly or even go with monthly reviews. So cloud providers will generally give you an invoice or send a billing alert every single end of the month. You are running a system that is live. So when the bills come in, you need to see the cost dashboard. So you can check out the breakdown for the costs, see what exactly you're being billed for. Are you actually using those resources? Do you need them to be used? Which pipeline is using them? Which part of the project is using them? So you need to investigate any underutilized instances or schedule off-hour shutdowns. If a system is using a resource and that system itself, you don't really need it running all the time, it's probably a good thing to have it powered down and not costly because the cloud works on a pay-as-you-go model. So what you've provisioned, what you've used, know what you're being paid billed for. If you have reserved instances, that is an entirely different thing because regardless of whether you use it or not, you have committed to having a resource for a number of years, 1 or 3 years. So make it useful. Try to use the resources that you've already provisioned or simply power down the resources you don't need to use. You can use budgeting alerts. This is for Azure cost management or AWS budget. So if a budget exceeds something, even MongoDB and other resources, other tools, they give you alerts for when your bill exceeds. So notice those alerts and work on them because if you keep exceeding the bill for every month, then chances are either you are not limiting the budget correctly or there's a spike in usage that either can't or can't be accounted for. Try to adjust the billing to match the actual usage states. You also have cost or performance. So compare instance families for optimal ratio. Don't cheap out at the expense of user experience. So when you're deploying a system, this is where you should probably have done this. Because if you provided the specs for a system to get deployed, the instances were provisioned, the auto scaling was set up. The primary site needs to be able to handle traffic so that you don't have to use the failover site or the scaling side. So did you accurately forecast the traffic to use it and what else needs to be changed? If you can hot swap any infrastructure, this could be the chance to make a case for upgrading it. Continued vigilance and optimization. We're probably near the end of the presentation. While we cover the core system maintenance, a truly resilient and efficient infrastructure demands ongoing curiosity and attention to detail. Some of the things you can look for aside from memory management, because if I see most developers now, they are interested in handling memory. Depending on the code you're using and which technologies and what you're using, which tools you have, memory management is really important because if you check the billing for most cloud providers, the vCPU cost is what really escalates the billing and the budget you'll get. So handle that properly. And then you also have API optimization, request, speed, security, scalability, and the integration. So refining endpoints to ensure that they don't really waste so much time in using it. So, and then also throttling the usage, the number of people that can use it at a time, requesting to an API. How does the API work with others? So try to optimize the APIs, and then there's also advanced security scanning. Yeah, security speaks for itself. You need to implement deeper and more frequent security scans to uncover hidden vulnerabilities and misconfigurations. Yeah, any questions on that? So maintenance sounds boring, but it's really what keeps everyone happy.
Chibuto, is that it?
Yeah, that's it.
All right, thank you. That was really deep. Um, so quick, but I hope we've picked up one or two things from the session. If you didn't notice, Kipruto shared the link to his slides on the chat. So if you felt if that was a bit fast, You could, okay, if you go to the chat box, you'll find it. You'll find the link there. And that was a wonderful presentation. I also have loved, and hey, you did a good job on the on the slides. It's very nice. Looks very nice as well. You also deep and quite good with the content in the slides as well. I was following through. I was even taking notes. So thank you, Kipruto. We have come to the Q&A section. Um, so, we open the floor to questions. So if you feel you have a question, I, for one, have a question, but I'm going to let you guys ask the questions first. Mimi hata tunaweza patana nyuma ya tent. But so if you have a question, kindly, as we mentioned, you can raise your hand, you can type it in the chat. Anyone with a question so far? Anyone? A comment? Perhaps? Maybe I'm going to mention names at this point. Pat, McCreen.
I suspected that I'll be mentioned. I don't know what's going on. So let me just comment so that okay, yeah. Firstly, thank you so much, Kipruto. That was really something. And true to what you said, maintenance is a very, very important phase of SDLC because at that phase we are actually managing things that are already in the prod environment. So it's very important to make sure that things are moving the way they're supposed to move. And you see, sometimes you think that app development or software development is about set and forget. You finish, you push, you forget. No, it's not. We must always do what we call management, and management comes in many flavors, including releasing future versions, adding features, fixing bugs, all that. And so this was really good. It was really eye-opening, and I'll do more reading. Thank you so much, Chirchir. That was really, really nice. Thank you.
Thank you, Pat. Thank you, Pat. Anyone else with a comment? Kwa sababu nyinyi mnakataa kuongea, I will. So thank you, Kipruto. One of the things that I've really struggled with for the past few months is maintaining the variables or maintaining configurations in the server. Where I am, all right, let me not talk about the specifics, but especially when you're working on or with on-prem servers, really struggle. And there's no pipeline that has been set up as CI/CD where you're making deployments manually. One of the struggles that I've really had is keeping track of some of the configurations that we've made. And that was one of the things that you mentioned actually early on in this session. And there's something you called it drift, where the production configuration no longer matches source control. I know you touched a bit on using Ansible, and there was another tool that you also mentioned. I think that was Terraform. And so that becomes a challenge for me now. I'm so sure maybe the other developers out there, maybe who haven't been trying out these tools. So just to be able to detect drift, and also try and stay, is it streamlined? If that's the word. But just making sure that whatever configurations you had set from the very beginning or what we really intend to use is what we remain with, especially in an environment where we're having multiple people pushing deployments on servers. And thank you for that. That was a really deep and insightful session. Asante sana, Kipruto. Thank you. You wanted to mention something?
Yeah, so drift it's a hell. Like you're trying to check what is wrong with this system, but you realize someone had the idea to increase the vCPU, or someone had the idea to change something in the cluster, and they didn't mention it anywhere. They probably didn't even go through. So State locking and seeing I think the name I keep for Ansible. There's the Ansible diff. You see, Ansible diff, you can run it and then it tells you what is exactly existing in the system, and then you can see what's the difference with what playbook you're trying to run. So if you have a pipeline that is working, that is only hosting the playbooks, you can prevent people from tinkering with it. So you only have one playbook working for everything. And then if someone is trying to run something, really ensure that not everyone should have permissions to execute things, especially with the playbooks, because one wrong thing with a playbook, you'll probably have someone resetting everything in the cluster. So have a pipeline to track it, state locking. That's the secret sauce.
Thank you so much, Kipruto. Maybe a follow-up on that would be if in an environment where we're not using any CI/CD tools, for instance, where if you're making deployments, maybe say on an EC2 instance, all you're doing is pushing or SCPing a jar file or a dist file into that server, then using Nginx to serve or to deploy that file or to run that Java service. So what way could such a person or such an organization maybe start using some of these tools, and what could be beginner friendly in a way that that learning curve would be slightly not too steep, if I could say? Or what would you recommend? What tools would you recommend for one who is maybe starting out in that phase?
We've also had that with some of the deployments. So you have a situation where nothing that you're using actually requires a CI/CD pipeline. But guess what? A CI/CD pipeline can be designed for every single situation you can think of. So even if you're moving the files, you can have yeah, what is it called? You can have the pipeline triggered when a file is changed or a change is done in a file. So that is the file changed? What is the change on the file? Push it to this specific stage of the stage of the VM. One of the tools we've been using, like as we usually use, is Azure DevOps. So with Azure DevOps, you have specific pipelines that work with files. So if a file is changed somewhere, the pipeline itself will check there's a change in the file, replicate it to the other side. It takes a fair bit of setup, but it works. So if you completely don't have any pipeline setup, one of the things you can do is start over. You don't have to use the exact same environment for any given time. We have talked about the redirection for DNS and Nginx. So create a duplicate environment. You can already check the specs for the resource you have. It's an EC2 instance. Check what does it do. Also, starting over helps you with the case where you can track any lag that you had when you're deploying the system. So current state of the thing, create a golden AMI image for the system, stick it into the pipeline, deploy that EC2 instance. Is the EC2 instance live? Now start connecting the CI/CD pipelines to it. If you're doing a change for a file, configure the pipeline to work for that, because I'm sure there are hooks that track files. I have not really used them because we use the DevOps. So you can always get into a project where you are rebuilding it, because it's a culture that develops over time. You might not have it right now, but trying to go over the process again, it also helps you to now create a new different culture where you are tracking everything for that system. So regardless of how simple it sounds, even if you're just moving one jar file from one place to another and then using Nginx, if you stick it into a pipeline, it saves you from having to log into the console every time. You also have control over the SDK. So if you can't really incorporate it, just rebuild it and then redirect traffic back to it. So that's probably what I would do if it was me.
Thank you. Pat, you have a question?
No, I just have a contribution. I like the question that you've asked about an organization that maybe is using ClickOps. You're using ClickOps, and then you've not also gone into CI/CD. And I like how Chirchir has answered that question. That yes, CI/CD can be okay. CI/CD needs not to be complex. it can actually be retrofitted to fit any system, to fit any organization, small, medium, large. It's very possible. And then now, even within the same CI/CD, you can actually ensure that your CI/CD pipeline works with the tools that you use for automation and configuration, such as Terraform. You can use Terraform maybe to provision your infrastructure in the cloud, and Ansible to configure it. And then you see, it does not matter even if an organization uses ClickOps, it's always possible for you to shift. To shift from ClickOps to automation, because automation makes work easy. Automation reduces human error. So you can actually do it, because I remember there's a place that I used to work, and what we used to do there, when I got there, I discovered that we have this many customers that we are serving, and every time we need to do things, we needed to go to the console, then use ClickOps to do ABCD, and then you find that there are problems with that. So what you do, you can actually come up with a private repository for the organization, and then just start by making those modules one step at a time. You make modules, maybe you can create Terraform modules to deploy simple things like instances, containers, if you need containers, and then you look for another tool that you can work with. And then I also like the fact that Chirchir mentioned Azure DevOps. Azure DevOps is ideal for Azure environments. And then there's also AWS code pipeline for AWS. And then, I don't know what GCP uses, but if you want to use a cloud agnostic CI/CD pipeline, maybe you can start with something like something as simple as GitHub Actions. GitHub Actions has a fairly good learning curve, and it's very easy to learn it and actually follow with it. So I think finally, there's something that Chirchir has said that I hope every engineer that is in this call will take home from this, and this is a matter of culture change. Culture change comes with mindset. So you just need to, you just first of all need to convince yourself that there is a lot of benefit that accrues from you automating these things rather than doing them using ClickOps. So I think that will be my contribution. Thank you.
Thank you, Pat. You've both talked about mindset, culture, just changing how you do things. Kipruto mentioned that there is no harm. At one point, you mentioned that there is no harm in starting over. And so maybe for some of you who have not tried it or are still using the traditional, the conventional way where you just manually click EC2 instance, and then you go and set up the that virtual environment, try using infrastructure as code. So I think, as I mentioned at the beginning, that we are here to learn. We are not all experts. Some of us are, I must mention. Yeah, because of course, Kipruto, Pat, Macreen, in this session, they're experts in their field, in this field. And so for those of us who are not experts, it's upon us to learn. We're here to tap into the wisdom that these people have. So this is why we're having these sessions, and this is why we're encouraging each and every one of us. Invite a friend. A friend who's in this space. A friend who's interested in DevOps, or who is interested in cloud or software development. Just invite your people. Ask them that they may join. Then we could learn together. Yes, Kipruto?
I have a reminder. I think
Yes.
there's a DevOps summit that is happening. It's a really, really big thing. If you guys have not got your ticket yet, please get a ticket for it. I think it's the DevOps summit, it's happening on next week. Patrick, is that right? Next week it's
yes, it's happening on 7th and I believe it's 7th and 8th.
Yes.
Of November.
Yeah. So
yeah, sure.
please try to come to it, because that is where you get the secrets for DevOps, and then unaweza how pros what can actually add to it. So guys, mkuje.
True.
Awesome. Again, we plug you to events. So again, we are all here to learn. We are here to grow in our careers, whether you're a freelancer, whether you're working or employed somewhere, you own your own business. The whole idea is that we get to learn. Knowledge is power. Again, knowledge is power. Awesome. So thank you guys for joining today's session. That was about maintenance. We'll definitely inform you on the next steps. Okay, thank you, Kipruto. You've shared the link on the DevOps Summit that's happening on the 7th and 8th of November. I've just checked on their website and I'm seeing if you're a student, at least you're getting 1,000 bob. A ticket goes for 1,000. The early bird for the other guys is 15, and then the rest, you can just check it from their website. But thank you for also sharing that resource. So asanteni sana, we have come to the end of our session. Thank you, Pat and Kipruto, for your contributions and answering questions. And so maybe just to remind us that if you'd like to join our community, Pat, if you could kindly share the link to our LinkedIn page, maybe also our WhatsApp community, if possible. Great. Also, if you would like to follow our speaker, today's speaker on LinkedIn, Kipruto, if you could kindly share your LinkedIn profile or any other resource where we could, find you and maybe connect with you at a personal level or even professional.
Okay, give me just a minute. I grab the link to our LinkedIn. My internet is a bit slow, but I'll get it.
I think I've got it. Let me share it.
Okay, cool. If you've got it, the better. Thank you.
All right. Cool. Or Pat, you could share it. Something is not happening here. Something's wrong. Right.
Have you found it?
Something is not right. But if you found it, you could share it. Thank you. Yeah, if you could also paste your profile.
Okay, let me see. Okay, so let's see if I can get.
Okay, thank you, Kipruto, for sharing your profile. We've also shared the CloudForceSky one chat.
There's a link to the website too.
Oh, that's the website. Let me see if I'll get the one to our to our LinkedIn.
I've shared it.
Oh, you've shared it. Awesome.
Yeah.
Thank you.
All right. So thank you, guys. Thank you also for your patience in waiting till the end. Maintenance, we've been told that's the longest and the costliest part, or the most costly in the SDLC phase or in any product development cycle. So, just make sure that you're ready. Don't start something if you're not willing to, go on with it, right? So that's it for today. So from all of us at CloudForceSky, we want to thank you for being part of this journey. We started from requirements gathering, and today we are closing it on maintenance. So we'd like to urge you to remain curious, keep building, keep learning, keep networking and meeting people. Na tupatane hiyo the DevOps Summit that's happening on November 7th to 8th. So thank you so much. Have yourselves a good night. You can leave at your own pleasure. Asanteni sana.
Thank you, Rima. Good night, everybody.
Right, guys.